There is a growing consensus in Washington that the Department of Defense must move to a wartime energy footing. That shift means localized energy independence, hardened infrastructure, and the ability to operate through disruption without relying on a fragile civilian grid. Representative Pat Harrigan has been one of the strongest advocates for this transition, particularly through his focus on co-locating small modular reactors and high-density data centers directly on military installations. That focus was not rhetorical. It was formalized through amendments he secured in the FY26 National Defense Authorization Act. Those provisions matter because they move the conversation from aspiration to execution. The FY26 NDAA directs the Department of Defense to conduct a feasibility study, with a report due to the House Armed Services Committee by June 1st of 2026, examining the implications of placing SMRs and hardened data centers on base. The legislative intent is clear: optimize land use on existing installations, enable critical digital infrastructure to island from the civilian grid during cyber or kinetic attack, and modernize defense infrastructure by shifting massive computing loads onto private on-base nuclear power. That vision aligns cleanly with DoD energy resilience goals, but it also exposes a risk that must be addressed early, before billions are committed to concrete and steel. Power quality. DoD policy already makes clear that quality power is not optional. Under DoD Instruction 4170.11, installations are required to maintain available, reliable, and quality power for critical missions. Energy resilience is not defined by generation capacity alone, but by whether the system maintains performance under steady state and disrupted conditions. The Unified Facilities Criteria reinforce this point. UFC 3-50101 mandates analysis of voltage regulation and harmonic distortion in electrical designs. UFC 3554, published in March 2024, elevates power quality to a core performance metric for resilient microgrids and explicitly warns about instability risks introduced by inverter-based resources and nonlinear loads. At the equipment level, MIL STD 1399 and MIL STD 704 set strict limits on voltage ripple, frequency deviation, and harmonic content, because defense electronics, sensors, batteries, and control systems depend on clean electrical environments to function as designed. Taken together, the department already recognizes a simple truth: power that is present but electrically unstable does not support the mission. This matters directly to Representative Harrigan's SMR and data center strategy. Co-locating nuclear generation with high-density computing creates extraordinary advantages for resilience and grid independence. It also creates some of the most electrically complex environments the department has ever operated. Large-scale data centers generate nonlinear loads, fast transients, and harmonic distortion. Advanced nuclear systems rely on sensitive power electronics that can trip or degrade under unstable conditions. If these systems are paired without active power quality correction, the result can be paradoxical. You gain generation security, but you introduce operational fragility inside the fence line. From a DoD perspective, that fragility has consequences. A data center that drops workloads due to electrical instability is not resilient. A microreactor that trips offline due to harmonics has failed the availability standard even if fuel is available. Under recent guidance from the Assistant Secretary of Defense for Energy Installations and Environment, critical mission energy loads are expected to meet a 99.9% availability threshold by 2030. Availability includes quality. Dirty power counts as downtime. What is notable is that this gap between policy and execution is not theoretical. It is already being addressed by practitioners who work at the intersection of defense energy, power electronics, and mission systems. One such effort is coming out of North Carolina. Companies like 3DFS, founded by engineers who have worked directly with defense microgrids and high-consequence power environments, are focused on the exact problem the NDAA is now surfacing: how to actively correct power quality in real time so advanced generation and advanced loads can coexist without degrading each other. This is not about adding more hardware or oversizing systems. It is about software-defined control of electricity itself, stabilizing waveforms, suppressing harmonics, and protecting both the generator and the mission load at the same time. The relevance here is not regional pride, it is alignment. Representative Harrigan's legislative push is forcing the department to confront operational feasibility. DoD policy already requires quality power. The technology to close that gap is emerging from the same industrial base he represents. If the goal is a true wartime footing, then energy systems must be designed the way weapons systems are designed, with attention to failure modes, degradation over time, and the conditions that quietly undermine performance at scale. Generation without quality control does not meet the standards the department itself has already set. The policy is in place. The mandate exists. The opportunity now is to integrate power quality as a first-class requirement into the SMR and data center architectures the NDAA is accelerating. That is how localized nuclear power becomes a force multiplier rather than a hidden vulnerability.